So thanks everybody for participating. It would be awkward if I was talking to an empty room, so thank you very much. Certainly appreciate it. My name obviously is Kieren Norton. I'm the cyber AI leader for Deloitte. We actually talk about it as cyber AI and automation because we find that the two often go hand in hand in order to extract value. So when I talk today, I'm going to talk about cyber both from an AI perspective, both Gen AI, AI ML, as well as automation, and I'll be mixing those kind of concepts together as I go through the talk. Overall, I've actually been in IT for about 30 years, more than 20 in cyber specifically. This is where you guys say, no, you can't possibly be that old, right? But I've been at this a long time. So a lot of that time has been spent specifically around emerging tech, which is why I find myself in the role that I'm in today. Just a quick show of hands. Who here is in a cyber role? Okay, large amount. Data science and AI? Okay, few. What about product management development? A couple. All right, so I will try and shape my comments accordingly. So we're actually, the focus of today's discussion is going to be around three key questions, right? What are the current trends in the evolving AI landscape? How do we harness AI in the business of cyber to do basically cyber self-defense better? And then what are five key opportunities in cyber and AI today? I'm going to cheat a little bit because I'm going to talk about more than 5 use cases, but I'm going to talk about them at a high level, and then I'll get into details about 5 specifically. I'll also be talking, as I mentioned, both about AI and automation as I go through the use cases. But first, I'll start by setting some context around what's happening in the current landscape. All right, so obviously you guys know there's a lot happening in AI, and I'm not going to drain this slide. There's changes going on from a technology perspective super quickly. There's been over 350 million Llama downloads alone, multimodal models, et cetera. We're starting to see a shift from kind of initially what was really focused around productivity and co-pilots to building agents to automate and deliver like more kind of complete services. We're also seeing an expansion of what used to predominantly be cloud-based AI systems to on-device LLMs, small LMs, as well as hybrid AI. And I think we're actually going to see an increase in hybrid AI going forward because of a lot of the data privacy and security concerns. From a vendor's landscape, lots of new companies. I think of the recent unicorns, 60% are Gen AI related. So clearly there's a lot of hype and excitement around Gen AI as a whole. And then we have new sort of categories like independent GPU cloud providers. So these are folks who are providing GPU capacity through the cloud that are not specifically AWS or others, but they're actually trying to do it at a kind of a more effective and price point and workload perspective. Enterprise adoption, what we see is that a lot of companies started with piloting and trying to build, prototypes and so forth, but now they're really desiring to get into full production to realize the full value of the concepts they've been exploring. And then initially we saw AI being adopted by enterprises mostly for productivity purposes, I mentioned, but now we see the more advanced clients actually building AI into their services and products directly. From a user adoption perspective, obviously, ChatGPT was the Apple moment, right? The iPhone moment for a lot of consumers as it relates to Gen AI. But we're also seeing increased use of Gen AI by threat actors, right? So unfortunately, that's going to lead to certain risks and so forth, which we'll talk about a little bit today. But most of today's conversation is going to be about how you can use AI in cyber as opposed to how is cyber the enabler for AI, right? And so if you're interested in cyber as an enabler for AI, you could Google search debrief Deloitte AI fueled business. And that's a recent session we did specifically on how do you address the risks associated with the use of AI. Rules and regulation, obviously very fluid. I think right now there's more than 1,000 policy efforts going on across 69 different countries. So that's obviously going to take a while to rationalize itself. And then there's still some uncertainty around copyright, fair use, and so forth. And then from a job market and talent perspective, obviously it's hard to find people to work on AI, but it's also hard to estimate or help people understand the impact of working with AI themselves. So as I mentioned, if you're interested in cyber is the enabler of AI, please go check out that debrief. It'll be helpful, and it covers a lot of kind of the same concepts, but more about how you build applications securely, et cetera. So with all those changes going on in the market and all that, and by the way, the pace of change is like nothing I've ever seen before. Again, I'm old, I've been around a while. I saw client server, half you don't know what that is. I saw the rise of the internet, cloud adoption, et cetera, the mobile devices in the enterprise. This is by far faster, makes those look like turtles. It's really kind of hard to imagine how quickly this is moving. So with all of that change going on, how do you know where to start, right? So if you're a cyber leader, you're in cyber, you know there's value in AI, but you're trying to figure out, okay, well, what do I go after first? What's the first problem I can solve? So for those who don't know, Deloitte's the largest cyber practice in the world. We have been for more than 10 years. We're out there talking to clients in a lot of places across a lot of geographies, work with the analysts, we do our primary research. And so we're constantly looking at that. And as of right now, what we see is the most focus around the 5 areas in the boxes on the slide. That's what we hear from clients most, that they're interested, they're thinking about, or they're actually working on, right? So the first is around security compliance optimization. Everybody loves security compliance. It's a joke. So it's really focused on how do we make that faster? How do we make that more efficient? How do we make it less painful? How do we do it in better and more consistent way, right? Threat detection and response. Obviously, this is a priority one for a lot of folks. In that case, we're thinking about how do we, again, make it more efficient, but how do we respond and get to remediation more quickly, right? How can we reduce the time window that we have an exposure down by a significant percentage? Secure software development lifecycle, that is what it sounds. It's embedding cyber capabilities into the software lifecycle, so you're building and deploying secure systems. Attack surface management is another area. You guys are familiar with that. Again, it's how do we reduce the level of effort? How do we speed up the process? How do we make it easier? How do we make it more effective? And the last one, I'm cheating here a little bit, secure AI enablement. The reason I say I'm cheating is because that's not so much something you build with AI. It's really a process you need to have in place in order to build AI systems in a secure fashion, and you really can't do the first 4 without the last one, right? So underneath each of the boxes, there's a list of use cases we've heard clients discuss and be focused on, et cetera. So we're going to talk about third-party risk management in some detail shortly. Identity access management, we hear a lot of interest about improving identity operations, as well as tackling certain issues, challenges like recertification and making that a more efficient process for the business. Risk assessment, similar to actually third party, risk assessments historically involve lots of paper and review of documents and information, synthesizing that information, matching that up against a framework and coming to an answer. And so that's another case where there's lots of opportunities for efficiency gains, effectiveness gains, and so forth. Threat detection and response, the first one there is SOC transformation and digital analysts. So we're going to talk about digital analysts. It's a smaller bite-sized chunk of SOC transformation. But SOC transformation as a whole is one of, I would say, one of the top priorities we see, and it's actually an area where you can gain a lot of value, right? So it's often the space that, our clients are starting with from a cyber perspective. I actually was on the Threat Vector podcast about a month ago, talking about SOC transformation. The name of it is AI native SOC. So if you're interested in that topic, that will give you more details around it. But effectively, you're working on SOC transformation. You're actually hitting all of the use cases on that part of the slide. Secure software development, obviously secured code integration, automation, ticket generation, attack surface management. We're actually going to talk about automated vulnerability testing or remediation specifically, but we also see a lot of action around AI-enhanced red teaming, so using AI to make red teaming more effective, as opposed to red teaming AI systems, which is also something that's obviously going on. There's commercial products in that space, and that's also one of the places where we see a lot of initial interest. And then secure AI enablement, it's really about having an AI governance and a risk framework and embedding that into your systems and processes, and we'll talk about that too. All right. So the use cases themselves. We're going to start off with third-party risk management. So this is in the security compliance optimization bucket. Historically, I think most of you are familiar with this topic. It's regulated in many cases, but most companies have a third-party security risk management process and system. And so traditionally it involves getting evidence from a vendor, collecting information in the form of a questionnaire or other means, comparing that to a framework which is usually based on the company policies and regulatory requirements, doing the analysis, identifying gaps, and going back to the vendor to say, hey, these are the things we're concerned about, either you don't have or your answers are confusing, et cetera, and getting clarification. It's a very manual process, right? And it's time intensive. And so we do that kind of work ourselves, and we'll do it as an outsourced service provider for large companies. And so we're doing thousands and thousands of these a year. So we looked at it and said, well, how do we improve that process? So we've built an agent, and you can define agent in a different way, but we've built an agent where it will actually work with the analyst to improve the process, speed up the process, et cetera. And so basically the end user, the analyst, is using a web application. They upload the evidence, they upload the questionnaire set, right, the framework that they're doing the analysis against, and all the third-party responses and information provided. The agent then takes all that information. It's typically in PDF, so it'll break it down. It'll take the text, extract the text. It'll create embeddings, store it in vector. You use vector storage for temporary storage in memory. It says on the slide Llama 2, but we're actually using Llama 3.2 because it performs far faster, we found. Generating responses, and then TensorFlow is used to analyze the responses for similarity and alignment analysis, right? So that's all happening behind the scene. What the analyst sees is a response from the agent that lists every question in the framework. It identifies what the answer is and where the answer has been provided by the vendor with links back to the documentation or the questionnaire provided. It gives a confidence score as to how well that aligns to the requirement. And it will also identify where there's a gap or a conflict between documentation provided and what the answers were in a questionnaire, right? So the analyst goes from doing all that analysis themselves to doing the human in the loop work. So they're going through, they're looking at the gaps, they're double checking just to make sure where it says it's highly aligned and it's accurate it is, and they're moving on. So we're actually using this currently. We found that on a given review, we save 40 to 60% of the time that we used to take, and that obviously adds up over the course of a year. So I like this one because you see, obviously at the bottom, you got the benefits there, the operational cost and efficiency. It's a more standardized process, more consistent process, and obviously reduced manual effort. And again, this isn't necessarily like, okay, now we can get rid of people. That's not what we're looking at. In most cases, it's not what you're looking at either. You're like, how can I use those people to do higher value tasks, right? And so it frees up more time. So I'll go ahead and hit the next one. SOC transformation, digital analyst. So similarly, this is in the threat detection and response space, but we're still focused on the analyst, a different analyst, obviously SOC analyst in this case. So traditionally in the SOC, right, we have thousands and millions and billions of events coming in, thousands of alerts being produced. SOC analysts are typically looking at a lot of them. They're usually overwhelmed with the volume. There's also a high degree of burnout, alert fatigue, et cetera. And so that's been a real challenge in terms of the amount of data coming in versus the amount of data we can handle with humans, right? So the digital analyst, it was a direction we went to actually help solve for that problem, right? So in this case, we've been in the MSSP business for 10 plus years. We have the entire history of event, alert, and ticket and resolution information, right? So we're leveraging that now. So when an alert is fired, it still goes through the pre-processing stuff. We're not just taking events straight from 47 tools and throwing it at the analyst. We don't do that to our human analysts either. So we're still doing the data normalization, the data stitching, the pre-processing. we're taking care of the easy stuff, right? The obvious stuff, either sending it down a notification path, auto remediation, or if we know it's a false positive, removing it. So it's just the alerts that are actually pretty real that hit our human analysts today, and now they're hitting the digital analyst, right? So what the digital analyst does is it takes that information coming in from the alert, it adds context to it, right? So pulls other tools to pull additional information in, and then it goes back and looks at our entire ticket history, right, and the resolutions, and comes back with a recommendation on what it is and how to resolve it, including steps that they should take. So now the analysts went from having to do that all themselves to reviewing, the results provided by the digital analyst and doing a validation and making a determination. Now what we've also done is we've integrated the analyst with our ticketing system. So many, typically Jira, ServiceNow, et cetera. And so the analyst is actually staying within the workflow of the ticketing system, and this information comes to them in an alert, right? And so they're reviewing it, and they can action it right then and there and continue on. So in our testing so far, we're saving about 30% per incident, and the numbers there are at the top are the volume we're playing with, right? So, typically it's about 22 minutes per alert. We see 9,500, kind of real alerts a month. It takes about 3,500 hours to resolve those. You extrapolate that out, we're talking about more than 40,000 hours a year. And if we can get, from 30 to 50 or perhaps higher, it's a significant savings for us. It also makes the analyst's life a whole lot better. I'll mention in that case, what we're using from a technology perspective is Gemini. That just happened to be the right fit for the use case. We're not, we've recognized that different use cases typically require different tech. So you have to do some testing, you have to be willing to try a few things and fail in order to find and improve the answer. So going forward on digital analysts, we're gonna do two things. We're trying a new technique, which is using a prompting tree, right? Where basically the agent will provide a tree structure of prompts and will choose one and go down it. The analyst will be able to say, hey, actually you went the wrong way. Instead of this tree, you should have selected this tree. And that's gonna then feed back into the analyst to improve its capability. And we found that's important because in more complicated alerts, or more alerts that have less specific details to them, that's really the area that we're trying to tackle and improve upon based on what we've learned so far. The other thing we're going to do is eventually integrate it with direct auto remediation. So more to come there. All right. Next one, automated vulnerability testing and remediation. So under the attack surface management umbrella, everyone's familiar with vulnerability management, patching, configuration management, et cetera. What we're trying to do is we're trying to reduce the time and the effort to get from notification, identification of a vulnerability, all the way through to testing of the deployment of a patch or configuration change to fix that vulnerability. And we're trying to take the humans out of it as much as possible. So the way that works is it starts with aggregating all of the vulnerability information. So it can come from your vulnerability scanners, your endpoint devices, et cetera. We all have 30 to 500 systems that produce vulnerability information. So we aggregate that in a data lake, and then we'll do a validation of what we're seeing. So typically, if the endpoint system is reporting of a vulnerability, you do. But sometimes the endpoint agent isn't properly deployed on the asset. And so there's an asset out there that's vulnerable and you don't know about it. So what we do is we take all the authoritative source information from the vulnerability identification tools, and we actually compare that to the entire footprint in the cloud and determine, is there a delta where you have assets that are not being reported by the vulnerability tools, right? And if so, we flag those, send them through SOAR, generate a ticket to go get those fixed and added to the asset list and get them properly configured, et cetera. So the next step after that is contextualization and prioritization. So we'll take the metadata around all of those vulnerabilities, right? So think CVEs. We extract that. We generate a unique list of all the CVEs that have been identified in that set of information. We then bounce that against an LLM, right, to pull back information around exploitability, ease of exploit, criticality, et cetera. We then match that with contextual information we've gathered from the cloud. Where does the asset sit? Does it have a direct connect to the internet? How many other assets talk to it? What does our identity access management or asset tagging tell us about the criticality of that asset, right? So in doing that, we reprioritize the list, because a critical vulnerability on a server that's sitting in a directly internet connectable environment is actually a higher priority than one that's in an isolated lab segmented for most of the network. And so the goal is to take that information, reprioritize, and then basically group them by asset and criticality, so you can create a work package that has to get done, right? So now you know the assets, you've prioritized them based on the context, you've grouped them together so you know how to knock them out. It adds the actual steps for how to remediate each of the vulnerabilities identified, and then ultimately puts that into a ticket in ITSM for approval by either someone from the business or cyber, changes depending upon how you're set up. So when they go into the system and they approve it, right, it's showing them all the assets again, all the vulnerabilities, the remediation steps to be taken. They say, yes, I want to go ahead and automatically validate that. Then the agent will stand up a new isolated cloud environment. It will instantiate each asset type, right, based on standard images. And then we'll compare those assets against production. If production is configured differently, it will take a snapshot of production and drop it into the same isolated environment, and then we'll automatically deploy the patch or the configuration change, et cetera. After it's completed that process, it'll scan it, and it'll then come back and say, yes, it worked, or no, it didn't. It'll detect both failure to patch, it'll detect, failure upon patching, which everybody's familiar with. We used to test patches all the time, by the way. So over the years, somewhere we got to the point where we weren't testing them anymore, so occasionally you do have an issue. But it will also determine whether or not it's caused disruption, whether or not it's introduced another vulnerability into the environment by patching something, et cetera, and then generates a report to say this is successful or not, and here's why. Now, we're not to the point where we can then go do that in production, because the world of production is just too complicated, too many variables. But at least at that point you've automated the entire testing process as far as you can go, and then you're now applying human in the loop process before you go apply to production, right? So I know I'm covering these pretty quickly, but I'm going to jump to the next one. Secure software development lifecycle with AI. So I'm not actually going to spend too much time on this because it overlaps a little bit with two of the other ones I'm going to talk about. But effectively, this is embedding security controls into the software development lifecycle. We've been talking about a lot of these principles as DevSecOps for a number of years. This is actually implementing it in a real way, trying to make it as efficient as possible, as well as using a couple of techniques to sort of improve the outcomes. We do have a white paper that we've written about this in much more detail. So if you search on Deloitte Zero Trust SSDL, you'll find it. And it goes into a lot of the specifics around the technology and how it works and so forth. But quickly, obviously you want to be integrated into the IDE where the development work is being done. You want to be looking at code that as it's being, actually typed into the IDE to flag vulnerabilities as they're created. You then look at that code again upon submit. When it goes to the repository, you can kick it back if there's vulnerabilities, or at least let them know and say, hey, here's the vulnerability, but by the way, here's the fix, click here, right? So you're taking the level of work down for the developer. Once it's in version control, again, you continue to scan for IAC type vulnerabilities and push those out. Once it's in the pipeline, you're detecting anomalies and enforcing those custom policies, right, all the way through the pipeline. And then once you get to deployment in the cloud, or leveraging assets in the cloud, there's a couple of things to talk about here. So one is CSPM. I think most people probably are familiar with Cloud Security Posture Management. That's a very effective tool. It can identify a lot of vulnerabilities in the cloud, et cetera, but it can also create a flood, right? And so it's creating the flood. That's where we do two things. Number one, we look at aggregating, automating, and orchestrating as much of that as possible. So taking all the information we're getting, then going through and deduping, normalizing the data, et cetera. Because what we find is that if CSPM picks up something in the cloud, probably 7 other tools pick up that same thing in the cloud and report them through different consoles, right? And so rather than feed all that into the SOC, contributing to the problem we're trying to solve for in the other use case, we want to rationalize and normalize that data down as much as possible. So we're sending the high value events and alerts into the SOC, right? And then as we talk about AI, Gen AI automated ticket notification, that's really what we were talking about just a few minutes ago. So again, more details on this in the white paper if you'd like to see it. I will keep going. All right, secure by design. So this is the last box that we talked about. This is really creating a process for embedding security into the development of AI systems and solutions, right? This is not DevSecOps. This is a level up from there, right? So think about this as the ITSM orchestration layer. So today, people are mostly concerned relative to AI and adoption. Their primary concerns are security number one, privacy number two, right? But there's others. And so in a regulated environment, you're going to have 20 different tests that have to be done before something goes to production. And talking about AI, it's going to be 27, right? And I'm making up numbers, but you get the idea. So what we are recommending is taking your process, embedding it into your ITSM so that you can manage this with more workflow, automation, and efficiency in order to develop solutions like we talked about previously, but doing it in a secure fashion, right? So I'll quickly run through this. Intake and scoping. So when a project is created, creating the profile within the ITSM system, that becomes the baseline by which you determine what controls need to be applied, as well as what tests need to be done. That obviously kicks off workflows accordingly. The testing gets done in an automated fashion where possible. So instead of a human going and doing the vulnerability scan or doing the code review, et cetera, you're automating that. And then you're capturing those results, pushing it through for approvals, and making the process for approval easier by coordinating it from end to end. So more on that. It actually shows up in the debrief that I mentioned as well. I think I'm out of time, so thank you guys very much for listening.